Okay, in this video, we're going to learn how to calculate a Pearson R by hand. So where we are in our outlines is we're in descriptive research techniques, and we're going to focus on using a raw score, using this big nasty formula here to calculate the Pearson R. Now, in class, we'll talk about how you determine whether or not it is statistically significant or not. We're also probably going to do a Spearman Rho in this video because that's pretty easy to do too for the hand calculations as well. Okay, so that's what we're going to do. We're just going to learn how to take the numbers and convert them into a Pearson R. So here is the formula. Let me zoom in a little bit here. So here's the formula, and I'll explain that to you. So the Pearson R is equal to all of this stuff here. So let's break it down. In this particular formula refers to the number of pairs of scores. Remember, with the Pearson R, you have to have a measurement on both variables, so pairs of scores. So if you're missing some data, you're not going to use just one data point. So it's N is the pairs of scores here. Sigma is the same as what sigma meant before. It means to sum up whatever is to the right of this symbol. And in this case, it's telling you to sum up your x variable times your y variable. So as you can see, one of the values we're going to have to calculate, is we're going to take our x value, and it doesn't matter what you call x and y, as long as you keep them constant for your calculation, but that's arbitrary. But you're going to take your x value and multiply it by your y value for each pair of score, right? And that's the value that would go in there. And then from that, you're going to subtract what's in parentheses here, which is the sum of your x variable, just like when we calculated the mean. And you're going to do the same thing, the sum of the y variable. And you're going to divide that by this denominator, which is the square root of, again, pairs of scores. Now we have, just like with our standard deviation and variance, we have the sum of x squared. So what we're going to do is square each of the x values. And that value, sum them up, and that will be this value that will go in here. This, we're going to sum up all of our x values, so it'll be the same as this value here, but then we'll square it. Same thing for our y variable under this particular term, and then we would multiply them. So let's look at an example. And so in this example, it's a very simple example. We're going to give two scales on a scale of 1 to 10. And this measures the attitudes toward gun control, 10 being you favor gun control, and your opinion of the NRA, the National Riflemen's Association. And we expect that these two things are going to be highly correlated. And again, your scale of 1 to 10, 10, you strongly disagree with the disagree with the policies of the NRA. Okay, so what we're going to do is we're going to correlate these two measures. So here's our people, and we got their ratings from each of these scales. And now we need a few things. We need a few entities. So all I did was relist our x values here. And I relisted our y values. Now I do it like this because I think it's very simple to keep everything straight and organized. Because as you can see in this row here, I've just summed up whatever's in the column. So we're going to need the sum of x. So when you add 1, 3, 4, 6, and 7, you sum that up. The sum of x is 21. We're going to do the same thing for y. And the sum of y would be 22. Now, if you go back and look at the formula, we need x squared. So 1 squared, 3 squared, 4 squared, 6 squared, 7 squared. That's where those values came from. When you add these up, you're going to get 111. Same thing for y. 2 squared, 5 squared, 3 squared, 7 squared, 5 squared. You add all of them up, you get 112. Now this last little column here, this is x times y. So what you're going to do is take your x value, multiply it by the same person's y value. So 1 times 2 is 2, 3 times 5 is 15, and so on. And so you have x times y, and then this would be the sum of x, y. So now you just substitute each of these values into the appropriate place in the formula, right? So n is number of pairs of scores. We had 5. 106 goes here, right? Sum of x was 21. Sum of y was 22. N was 5. Sum of x squared, this value, was 111. So that's what that number. 21 is the same here, right? Just like 22 is the same here. 5 again, pairs of scores. Sum of y squared was 112. So now you substitute it into your formula. Now it's a matter of solving, right? So the way I would solve it is first I would multiply these numbers and multiply these numbers in that step, right? The other thing you could do is multiply these numbers and these two numbers and go ahead and square these two values, 21 squared and 22 squared. And so you get 530, 462, 555, 441, right? So the next step is then to reduce. So you're going to reduce 530 minus 462, well that's 68. 555 minus 441, it's 114. 560 minus 44, 76. Multiply these two numbers. You get 8664, take the square root, you get that. 68 divided by 93.8 is the Pearson R 0.731. And in class we'll learn how to test whether or not this Pearson R is statistically significant or not. We'll talk about that. But that's how you calculate the Pearson R. Now the Spearman Rho is simple. It's even simpler. Here's the formula for Spearman Rho. So Spearman Rho, this is a Greek letter rho, and it's equal to 1 minus 6, and we'll explain what this is. It's the sum of d squared. I'll explain what d squared is in just a second. And then, of course, n is number of pairs of scores again. So d here is, remember, we're going to use Spearman Rho for rank order data. So if you are rank ordering two kinds of measures, and in this example, I'm using a real-life example in that graduate students in our program would get funding depending on their rankings from faculty members. So what you have is you have a graduate student, right? Here's a graduate student, and you have two professors who are ranking this graduate student, right? They're ranking them from 1 to 7 because we have 7 students here, and you want to know, are the rankings that Dr. Allen provides, are they correlated with the rankings that Dr. Bunnell provides? Hopefully they are, if they're using similar kinds of assessment criteria, right? So that's our rank order data. We want to know this, and now we want to know if they're correlated. So D is the rank on X minus the rank on Y. It's a difference score, right? So here are our rankings for each graduate student. So graduate student A was ranked number 2 by Dr. Allen, number 1 by Dr. Bunnell, and so on. Okay? So our D score is 2 minus 1, 3 minus 7, minus 4, and so on, right? All the way down, okay? And you can see I just summed this up for you. So if you sum D, you're going to get 0, right? So that's why we square it and put it into the formula. So we're going to have to square D, so 1 squared, minus 4 squared, and so on. Get rid of those negatives, right? So now we just plug into the formula. So we have 1 minus, and then you have 6, which is a constant sum of D squared. So that's our ranking score. Sum that up, 22. Pairs of scores. We had 7 pairs of scores. That goes into the bottom. Then you're going to reduce. Of course, you can do the math here. And your Spearman Rho is 0.607. So it appears like there's a strong positive correlation. But we would need to test this, and we'll learn in class how to test to see if this is statistically significant or not. But that's how you calculate a Spearman Rho and a Pearson R by